Good afternoon. My name is Jason Horak. It is June 23rd, 2012, and I'd like to talk about my Dodge Daytona electric vehicle. Specifically, I'm going to be making some changes to it, and I wanted to kind of document how it's set up right now, and then talk about what I'm going to do to change it in the very near future. So what we've got here is the engine compartment, which has 23 of the China Aviation Lithium Battery Company 180 amp hour cells. So these batteries are all I could really fit in here with the current layout. The reason why there's a cutout here is because that's over the transmission, which extends higher than the motor. So this is really as close as I could get it to make it fit. When I originally put the car together last July 2011. As you can see, there's a large plate here. This is an aluminum plate. I think it's a 1/4 inch thick. It's pretty hardy stuff, and that's what's holding up the tail shaft of the motor, and also providing a mounting point for the power steering pump, which is there. So the power steering pump is right here. And this is the stock power steering pump for this vehicle. It was actually in the car originally. I never removed it. I just moved it out of the side, or off to the side, while I was pulling out the original engine, and then built all the rest of the stuff around it. So that's that, and it actually works reasonably well. Whenever the whenever the motor spins, then the tail shaft spins, and thus so does the power steering pump. The downside of this setup is that you have to actually idle the motor in order to get power steering at times when, say, you're doing parallel parking or other fine maneuvers. That's fine for somebody who's actually used to driving it, but when I hand the keys to somebody who's never driven an electric car before, or specifically even a standard, everything else is easy for them except for the steering because of this power steering pump. So I'm going to change that. I have an electric power steering pump in my old EV that worked really well. It was just very annoyingly loud. And so my plan is to take that and then put it into this car. It's really hard to see the spot, but kind of behind everything there's a cutout where the old catalytic converter used to go for the exhaust system, and there's really not a lot going on down there. I've got some wires and so forth that go up the channel, but there's enough room to put the power steering pump in there, the electric one, once I move it over from the other car. So actually, let's go take a look at that other car just to show you what the power steering pump looks like and how I'm going to fit it in there and make it go. Be right back. Alright, this is the rest of my Dodge Daytona fleet. I have two 1986 Daytonas, Turbo Zs, and the one 1988 Pacifica that was the old electric car. So this is what previously had the motor and the controller and the charger and all that good stuff was in here, along with the electric power steering pump, and the batteries were the older Metropolitan Industries lead acid batteries. So there's lots of pictures that I've taken of the project, but anyway, these were the batteries. I've just got them in here for storage at the moment, and that is the power steering pump. So that's the whole power steering system. And so the high pressure line is the lower one that goes up there, and then the low pressure line goes up to the filler unit there and back on through. So as you can see, I've got it kind of jammed in here, but if I do the same kind of thing in the other car, it's going to allow us to free up a lot of space and also get back to having an electric power steering pump that isn't dependent on the spinning of the electric motor. So we're going to hook this up here just to some power so you can kind of hear how loud this thing is. So that's the noise that it makes at idle with no, straining on the wheel. As soon as you put any kind of pressure on the wheel, it's really obnoxious. But there's not a whole lot I can do about that. The only advantage to this is that I can turn it off when I want it to be quiet. So I guess that's something. And I'm going to do my best to kind of isolate it, surround it with as much sound dampening insulation as I can. But the reality is that it's a noisy unit, and it probably always will be. Anyway, so there we go. That's the old engine compartment from the old EV, and just kind of using that thing which is still hooked up for sizing. And I'm going to be moving that power steering system over to the new car and removing the stock power steering pump. Anyway, back to the other car. Alright, now that we're back to their car, we've talked about the power steering pump and the changes that we're going to make. Well, by removing that, not only are we going to be able to greatly reduce the size of this aluminum plate to just support the motor like it was designed to originally, and we're going to be able to free up a lot of space over here, because the batteries are currently kind of laid out like so. My plan is to take another battery like this, put it into this space right here parallel to that one, which will bring the battery box about out to here, give or take, and then extend this part of the box this way all the way over to here, and that should allow me to get at least 3 more cells in here. So it'll be 1 more here and then 3 more across, bringing the front pack up to 27 cells instead of 23. So that'll get me almost where I want to be. The other factor is you can kind of see this big metal plate here. I'd left this extension because I was thinking that maybe I would put a air conditioning compressor down here and run the belt off the pulley, which would have worked, but I'm thinking that if I do go with an air conditioner, it's going to be one of those Tecumseh air conditioning units that's all electric, and that would fit right into this nice empty cavity right here, and not take up any space away from my batteries. So what I'm going to do is try to take the last 3 of these batteries, so it's about that tall and about that wide, and they're going to go under here just like that. So you're going to see the terminals sticking out this end, and I'll be able to get at them to do measuring and that kind of thing, and it'll just be wired into the rest of the pack, probably right here on these 2 terminals, but we'll see how that works out. So we'll go from there to here. From here out, down to those cells, and then back up and into this next battery. So it'll kind of be, in place of this strap, will be these other 3 cells. So anyway, that's kind of the plan. In order to accomplish this, I've got to rip everything out. The motor mount is coming out, so that's got to be changed, and the motor has to be taken out, or at least supported and pulled. The battery box, the entire thing, has to come out, be modified, and be put back in. My high voltage wiring shelf, which is, wood, actually rests on supports that are screwed into this battery box. So all that's got to come out too. So pretty much I'm going to be gutting the entire engine compartment to do this little change. But it'll give me a good opportunity to evaluate things and then make some other changes that are kind of necessary. For example, the motor, which we'll go down here and take a look. And Soliton 1, positive one side and then the other side, and then underneath, take a look at the motor. So, this motor has been driven about 10,000 miles, and, through the winter, it's gotten kind of dirty and so forth, but it works extremely well. And one of the things that Jack Rickard on his EVTV program has been talking about is changing the brushes. These have stock brushes there that came back in 2009 when I bought this motor, and I'd like to replace them with the Hellwig split top brushes. I can get at a couple of them from down here with the battery box in without too much of a problem, but the ones that are on the top would be kind of a pain with the battery box right above it. So since I'm taking the battery box out and I'm changing this whole metal plate and everything, I figure now is as good a time as any to change those brushes and try to get a little more range, possibly a little more just general efficiency. Also, after recent changes to the Soliton, which is here, I beefed it up from 350 amps to 500 amps battery draw, and that's just a configuration setting that I had made kind of at random before. I picked 350, seemed like a good number, worked pretty well. The car was very peppy. It topped out at about 88 miles an hour. And, was fine. Well, I made a little change to that up to 500, and the controller, of course, is capable of 1,000, but I figured, alright, we'll try 500, and now the car does 100 miles an hour without even thinking about it, and is quite a bit more peppy on the takeoff. So, with that change, I've noticed that my clutch has been slipping. So the clutch used to hold pretty well with the old power, and now it's been slipping pretty good, so I'm going to change the clutch to a racing style clutch. And again, since I got to take everything apart anyway, now's a good time to do it. So we'll be swapping out that clutch with a center force dual friction racing clutch, which is supposed to be easy clutch pedal pressure, so you don't have to put a lot of pressure on the pedal, but you can still has a lot more clamping force that will hold that torque coming out of that electric motor. That's the theory anyway. We shall see. I'm also switching from the original steel flywheel, which is very heavy, over to an aluminum flywheel. And the aluminum flywheel is supposed to have, just by virtue of its less weight, less rotational, it takes less energy to make it go, to put it into terms that I can understand. So the point is that I should be able to get quicker acceleration, I think is the theory there. And so I've got a much stronger clutch and less mass that I'm trying to spin around on that flywheel, and it should make a big difference. I don't know, we'll see. Time will tell. Always worth the experimentation here. Kind of taking a page from the racing crew. Lastly, this is my 12 volt system, so I've got a little motorcycle battery that gives me 12 volts when the car is off, generally, and then whenever it's on, this Vicor Megapack unit, which is actually a computer power supply, puts out about 14.8 volts, and that's done with these little 5-volt modules that are wired parallel, in parallel here, which gives, each one has a 40 amp output. So by putting them in parallel, you get 80 amps per 5 volts, and then they're wired in series, which makes the whole thing put out, again, right around 14.8 volts at 80 amps. Now that's enough to run everything in the car, including the electric power steering pump, very efficiently, and electric motors and the windows and all that other fun stuff, without even breaking a sweat. The downside is this thing is extremely loud, and I will demonstrate that by turning it on. So this is, turn on the car. Cool little gas or gauge there. So right now it's kind of hard to see with the glare, but the bottom left is the battery indicator. So it's pretty low, it's less than 12 volts, and draining quickly out of that little motorcycle battery. What we're going to do is turn on this switch right here, which turns on the Vicor Megapack. And now you can see we're much higher. This is probably, well, 14.8 volts, I'm guessing. And the downside, though, is it's really loud. As you can hear, it's obnoxious. I'd like to eliminate that. That's another part of my master plan for this upgrade, is to take out this unit, this battery, and these two contactors. The one in the back is for the high voltage, and the one in the front is for low voltage. And the idea is that it has to be switched on both ends, because otherwise this battery will be drained through this whenever it's turned off. I don't know why that happens, but by putting a mechanical or electrical switch rather in between there, it prevents it from draining. So anyway, really loud and obnoxious for a car that's otherwise very, very quiet. So what we're going to do is turn that to back off, just to keep the noise level down in the video. And as you can see, it drops right down to, back to just running off that little accessory battery. But it's silent again. Now the car, of course, is on right now, and it's in neutral. So by turning this, which is the Soliton, the Evnetics throttle assembly, hooked up to the gas pedal, it spins the motor. And then in spinning the motor, we also spin the power steering pump. Now, as you can tell, the power steering pump is really freaking loud. So, we get a little bit of noise coming from the motor itself and spinning the transmission, but a lot of that noise and the squeaking and everything is coming from this belt. So I'll be happy to eliminate that source of annoyance as well by going back to the electric pump, which is constantly annoying instead of only annoying when you turn. So I don't know. We'll see. Maybe there'll be a better solution someday, but for right now, that's the best I got. And the only advantage to the electric pump, as I mentioned before, is that you can turn it off, and the car still drives with no power steering, and it'll be whisper quiet. So that'll be nice. So anyway, just to finish up the topic of the DC to DC converter, I have one on order from Jack Rickard at EVTV. That is the Chinik 192 volt rated unit that's supposed to go from, I think, 157 volts on the low end to 220 on the high end. So for my pack, that should be perfect. I'm never going to run into a situation where I'm higher than that. If I get above 120, then I've already damaged all my batteries past recognition anyway, or 220 rather. So anyway, well, that's pretty much it for today. Just kind of wanted to give you guys an overview of how the car is as of June 23rd, 2012, and hopefully there will be many changes to come in the near future. All these extra batteries will be gone out of the back, and not looks quite so bad. And all the weight will be moved to the front, which gives me a much closer 50-50 weight distribution, at least in terms of the batteries, which are the heaviest component. Then adding in the weight of the motor and so forth will be pretty close to the stock kind of setup, and I'm still anticipating around 500 pounds more overall, but again, evenly distributed front and back really isn't too bad. And there you go. Anyway, this is Jason. I will catch up with everyone later. Have a wonderful day.